we have 6 equations, right? So you use each two to find out. You can finally obtain hx equals to kc squared on j over kc squared, and then kc is what we derived. Remember, okay, kc is colorful wave number, and have some relationship of Ez and Hz. What did you see? What did you see? Your direction, x direction, H field will equal to your z direction of E and H. And you have some calculation after you know Ez and Hz. Which never show up before, right? Remember here? Ez and Hz never show up in the TEM mode. It show up only when we calculate this special general case. Ez and Hz, they never happened. But now, if you know Ez, Hz, it is a clue to calculate your Hx, Hy, Ex, and Ey. All of them came from Ez and Hz. If you don't believe me, go home and do the calculation for other 3 equations. I don't think any of you will waste your time to do that. It's enough we do one of them, right? It's enough. But for the rest of 3, you just believe your textbook. You find out that. And Kc is the color frequency, and equals to Kc squared equals to K squared minus 2 beta squared. Okay. What we are going to do next week is first solve Ez Hz. After you solve Ez and Hz, and you have everything from this page. Understand? If you want to solve all the E field and the H field, you solve Ez and the Hz. They are the key. They are the keys. After you understand, you obtain, you solve Ez and Hz, you know everything from this page. You guys, you don't have a response, I am afraid. What is everything? I want to know the total E and total H, right? So for the total E, you have Ex, Ey, Ez, you have Hx, Hy, and Hz. Then you have this relationship. So actually can simplify the question to, once you obtain your Ez, your Hz, and use these equations, you can have total E and H. Okay? So if you want to solve the total E and the total H, your first target is to find Ez and Hz and use these 4 equations. Okay? Okay. Somebody not hand, so I can continue. Okay? Sorry. Now we are talking about T about mode today. After the equation, we start to discuss about the mode. From these four equations, okay, first of all, we try to understand what is TEM. Okay, this is transverse is the same word. Is because I don't think everyone knows this word, so I try to write down Chinese. Okay, TEM is transverse electromagnetic wave. Okay, transverse. What does it mean? That means transverse. The transverse. If you propagate in z direction, your E field and the H field, they are on the transverse plane. Okay? Then you can also transfer the TEM mode, the words, to the mass. What does TEM mode mean? TEM means EZ is 0 and HZ is 0. This is what we learned before. So this is TEM mode. Okay? Let's guess what is TE mean. Okay, who else never answered the question yet today? Zhang Zejia. Yeah, no, Wang Deji first. Try to guess what is TE. Look at TEM means EZ 0, HZ 0. So TE means, I haven't told you yet, I know, but try to guess from the rule. Great. TETM. So I think who's next? Zhang Zejia. So what is TM? Yeah, great. Now all of you know. That's it. In math. Okay, let's look at this board. If this is TEM mode, your E equals to only EX and EY, there's no EZ and there's no HZ. Okay? But if this is only TE mode, it means your E is only EX and EY, but your H is HX, HY, and HZ. And for TM mode, it is EX, EY, EZ, and the H is only HX and HY. That's it. That's it. Understand? It's important. TE means no EZ. TM means no HZ. TEM means no EZ and no HZ. Okay. Okay, everyone not had, okay. Then I will ask more questions. Zhang Youyu, from these four equations, okay, to repeat to us again, what is TEM mode? Okay, EZ, E0, HZ 0, right? And as I told you, I will use these four equations. I will use these four equations. Okay, the four equations. Okay, so EZ is 0. 0 divided by Y is 0. Okay. 0 divided by X is 0 minus 0 is 0. So HX is 0. So there is no TEM mode because HX, HY, E, X, E, Y, they are all. So chapter 1 is wrong. Chapter 1 is wrong. Everything is 0. What we are doing for chapter 1? Who make a mistake? Zhang Youyu. Me or Koza? Choose one. Who make mistake to let you study chapter 1? Everything is 0. What we are wasting time? Who make mistake? No one. Good answer. Why? Why? Okay. Is that possible? They are 0 and the hx is not 0. When? What happened? If this is 0, of course, and this is 0, yes, I agree. And hx, hy, ex, ey, what happened? What happened on what situation they will not be 0? Zero divided by something is not 0. What's that? 0. Yes. Right? 0 divided by 0, sometimes it happened. It's not 0. That is the L'Hopital's rule. Only if Kc is 0, they will not be 0. Only when Kc is 0. That's why this is Kc, cut-off wave number. So what is K? K, let me use the equation. So Kc is the square root of k squared minus beta squared. When is Kc 0? Only happen when k equals to beta. Everything makes sense. In TEM mode, beta is k. And the denominator is 0, numerator is 0, but they still have some result of E and H field. Okay? Makes sense. Everything makes sense. Okay? Nobody wrong. It's the correct answer. Everyone is correct. Yes. Okay. So L'Hopital's. I don't know how to pronounce. L'Hopital's. Do you know this rule before? 0 divided by 0 is not 0. Okay. Okay, so let's back to the equations. So 0, 0, green parts means 0, okay? Because there is no HZ, no EZ. So you can left only the black part. And we try to derive something. Try to remind us the wave equations. So this is a Laplace x E field plus this is k squared E equals to 0, and then you separate to see only the x component, but you still use a Laplace to everything here. Okay. And because you know your x component can be write down here, like there. The same one you write down exponential. And you take, for this two terms, you just wait. For this term, you take a partial differential twice to this one, and you will obtain the red box equals to the minus beta square. Okay, because minus j beta multiply minus j beta is minus beta square. Guys follow? You just do this one for this part equals to this one. And because we know the conclusion, beta square equals to, k square equals to beta square for TEM mode, right? So for a TEM mode, you should obtain this term can cancel, these two terms can cancel out each other. For TEM mode, we obtain the yellow equation. The partial, the twice of the partial differential respect to x plus to y squared to your x component of E equals to 0. This one has the component of x and the y, and also part of z. This part is this part. So they are not 0, okay? Can put this one back. Okay, so what do we obtain? For TEM mode, you have this one for EX component. Remember, we see only X component, and then we can also see for Y component, and we can also check the wave equation for H. Then you will have 4 equations for TEM mode. Write down 4 equations, and they all equals to 0 if you take this. Okay, for TEM mode, you obtain 4 equations. And this is a Laplacian equation, only x and y. And we can also obtain the result from the 6 equations. You will find the ratio between EX and the HY and the EY HX. Okay, those are 6 equations, and you can make more equations, and you find out the wave impedance for TEM mode. Wave impedance is a ratio between E and H, right? To separate X and Y, and this is what we solved before. Remember, we solved this in chapter 1, TEM mode. But we use the same technique for TE and TM. We need to know the impedance for TE mode and TM mode. And this is what we already did. And I just show you what we did before, and also we use the new equations. They're supposed to have the same result. Everything makes sense, right? Because there's no EZ, so they become no EZ and HZ for the 6 equations. Okay. Do you know what are they? So the first 3 is this 3, and there are another 3 on the whiteboard, right? So these 3 you can also make them an equation, and you make EZ and HZ equals to 0, and you find a ratio between H and E and H, and you find the eta. Okay, this is what we did before. A little bit review connected to connected to what we learned today. Okay, new stuff today. Now, for TE, EZ is 0. So for these 4 equations relevant to EZ and HZ, because EZ is 0, so you don't have this term, you don't have this term, this 4 term. So your EZ, your HX, HY, EX, EY can be simplified to only these 4 terms. And so what did you obtain? We need to obtain HZ can solve, and we can solve everything because we don't have EZ, right? So your first goal is to find HZ, and everything is done. Because there's no EZ for TE mode. So find HZ. This is what we will do next week for waveguide. Solve EZ, but solve HZ. Then write down everything. Okay? I know you don't know how to solve EZ. It's okay. Just tell the future you to understand how to solve HZ next week. Okay, we will solve HZ next week. But at this moment, you need to remember why we need HZ. Why is it important? Because after you know HZ, you know everything. You can have all the E field, all the H field, wave impedance, beta, VP, everything. Everything I want, everything you want. Just one thing, start is HZ, okay? And use the equations here, all right? And the thing here is, so KC is not 0 anymore. You need to solve the KC, K and the beta, right? EE mode. So this is TE wave, TE mode. You don't have EZ, but you have HZ. And HZ is the most important thing you need. Once you got HZ, you got everything from next page, the equation. Makes sense, huh? So, how to find HZ? Okay. We will do that for waveguide next week, but let's just briefly see what we can do, okay? How to solve HZ, how to solve HZ. And there are still maths, but you will have more, we will apply the boundary condition for waveguide. But here, we just see how we will do next week, okay? Maybe I will start from here next week, and we go deeper. But we just do a briefly preview about HZ. So this is a Maxwell equation. This is a wave equation, the same. And for the wave equation, you transfer omega square mu epsilon to k square, and for this is Laplace. Just write down the Laplace. Because we want to see HZ, so we see only the Z component, because our goal is try to find HZ, right? So HZ plus k square, HZ equals to 0. You just separate x, y, z. Okay? And you try to transfer the HZ, you take the Z part outside, because you know only if it is propagating in the Z direction, it is something multiplied by the exponential minus J beta Z. HZ equals to this one. when you take twice of the partial differential to the z, this component, because it has only the z part, like this term, so the partial differential, the second order of the partial differential equals to minus beta squared. This term is minus beta squared. Then you transfer this equation to here. You keep everything the same. You just transfer the second order of the partial z to minus beta squared. Okay. And you know beta squared, k squared minus beta squared equals to kc squared, right? This is what we define kc. Then you obtain your result can transfer to here. And because after all you will take the partial differential to only x and y, and you already get rid of you take partial differential to z because you already use this part. You don't need to take care of z, and this one equals to 0, which means you don't need to see the green part anymore. You need to make this equation to be true, equal to 0. Follow me? Are you follow? So our goal is to solve hz, and your capital Hz is this one multiply this one. This is, I think it's a little bit, I think I'll write it right now. This one is need colors. After you have this one, you can solve everything, right? And the Hz, it is this one multiplied by this one. You have a small, yeah, the same one. And multiply this one, it is capital Hz. And once you have capital Hz, you use the equation last page, you solve everything. You have capital Hz, put them inside. You have hx, hy, ex, ey. You solve everything. Okay? So what you need to do is to solve this equation. Solve this equation. Only one equation. You solve Hz from this equation, then you have everything. How to solve it, I will tell you next week. And once you have Hz, then you also have the relationship. And if you have these two, you can have a relationship to obtain the ratio between Ex and Hy. And from the first one, the number 4 equation, you can obtain the equation of the ratio from Ey to Hx. It's this one and this one, right? So the impedance of TE mode is this one equals to minus this equation equals to here, and then it's because k is not beta.
Professor, that is k0, right?
No, it's omega multiplied square root of epsilon mu. It's not 0. K0 is mu 0 epsilon 0, and this is you have some material. But if it is, we are talking about waveguide which has only air, it is K0. It depends on the material. This is a general. Sometimes I told you that, oh, it's K0 because we know it's air. We assume we use air waveguide. It depends on the material, and this is more general. Okay, remember K and the B, they are different. K and the B are different. This is the most important thing. Because they are different, so it is not TEM mode. You have HZ, then you have everything from the equation. I know this is new and this is hard, this is difficult. Maybe sometimes cannot accept this when you first time listen this one. Okay, it's not a big deal, but you need to get used to it if you want to understand waveguide. This one happened. Okay, and similar things apply to TM mode. Now you have only easy part, and just very complementary things. Yeah. The same thing. The first thing you need to do is you obtain EZ at the beginning, and you also use wave equation. The wave equation, you can obtain the equation here. Try to solve EZ, then you solve everything. Okay? And the TMO has an equation also for the wave impedance. You can see, go through the details. Okay, I will stop here, and next week we will try to solve HZ or EZ. Let's check. Yeah, EZ and HZ, and we know everything, and I will finish the class for next week. It's just, I think you guys' performance is good. You guys, I understand most of you can follow. Okay, that's good. That's a good thing. It's difficult, and you understand. After that, maybe you can read, or maybe you can watch some YouTube about this one, and then you read your textbook. Or if you have textbook, try to make sure if you understand the different mode. It's, I think, one of the important concept and difficult derivation. Not everyone can do that. So just keep working. Okay, so see you next week. Thank you.